Hi. So this talk is actually going to be about logs. And the reason why it is about logs is that when I signed up for this talk, I actually thought I would be speaking in a DevOps track. Okay, so I thought, okay, what's good for a DevOps track? Well, logs is always a good topic. Okay, and then I figured a few weeks ago that actually I will not be speaking in the DevOps track, but I'll be in the big data and analytics track. And then I thought, well, maybe I should change my talk, but maybe not. Because if you're interested in big data and analytics, then you probably have the problem that you have to ingest your data somehow, have to transform it somehow, and then put it somewhere else. And this is a pain. Okay? And this talk is going to be about how to ease that pain for you. Okay, a few words about who I am. I'm an Elasticsearch core developer. I joined Elasticsearch 1.5 years ago. And I basically joined because everybody's doing big data, and I also wanted to do big data. Yeah, I wanted to do data analysis, and which I'm really super interested in. Although I must admit that I'm now doing a lot of things at Elasticsearch, so a little bit of everything. And one thing that I would like to mention is that I have no ops background whatsoever. And this is bad. Okay? And this is bad for 2 reasons. So the first is I'm going to be touching many ops-related topics in this talk. So ask me all you want about Elasticsearch. If you want to know Kafka integration on your 100-node cluster that runs on AWS, okay, we'll see about if I'll be able to answer. Okay, but there's a second reason why this is really bad. And that is because that these 2 things, interested in data analysis, especially big data analysis, and not having an ops background, actually conflict. Because some of the biggest data that we're having lying around right now and that badly needs analysis are log files. Okay? Okay, so how do we solve this problem if you're somebody like me and you want to analyze log files? So I'm going to give a very brief introduction to the Elk stack. It is Elasticsearch, Logstash, and Kibana. And just a quick poll, who of you have ever used that? Oh, quite a few, huh? Okay, good. So this is going to be a very, very superficial, really beginner's introduction on what this is all about. Okay, so maybe those who just raised their hand might not be super interested. But then I'm going to talk a little bit about analytics with Elasticsearch. And then I'm going to show you Kibana 4, which just came out a few weeks ago. It's still in the beta. Which is the visualization part of this whole stack. Okay, so what is Elk? So it's basically 3 components. First component is Logstash, which will just allow you to easily ingest data, transform it, and output it to some other application. It has many inputs, many outputs. I'm going to talk about this in a minute. But the output that I will be talking about is Elasticsearch, the search engine and document store. And then once you have your data in Elasticsearch, because Elasticsearch really is more or less a back end, what you really want is look at your data. Okay? And the software that we have at Elasticsearch for that is called Kibana. Okay, this is the 3 components. But first, let's talk a little bit about data. So when you're dealing with data, and I'll exclusively talk about data that comes in the form of maybe messages or documents, just one unit, and it mainly contains a text. So in dealing with data, and you're really lucky, then maybe you pull your data from some sort of API. For example, you could pull it from IRC or from Twitter. If you get it from Twitter, what you get is this nicely formatted JSON document that has all the different entries in, lots of information, and you can easily take it and put it somewhere else or find out what this is all about. But if you're not so lucky, then you might actually be looking at logs. Okay, so let's look at some logs. Okay. Hold on. So what's going on in my system? So it's my system log right now. Right. So it starts off with a timestamp here. Okay. Next comes the host name. I've really renamed my computer, I think. Then there's a component that actually wrote the log, in this case HipChat. And then comes some message that would tell a system administrator or somebody who wrote the software what's actually happening right now. Okay. And this is basically unstructured text. Okay. So that's what a syslog looks like. So if you want to ingest a syslog, you would probably have to write or usually you would have to write, okay, your own little tool that parses the timestamp, that parses the host name, the component, and then maybe the text and puts it somewhere. Okay, but now you have different applications. They write different logs. And in this talk, I'll be talking about 2 data sets. So I'm just going to show an example of this. So one is this log here. So that starts very differently. It doesn't start with a timestamp. It starts with this number here. So this is really just an ever-increasing ID. Okay, and then comes another number. So who can tell me what this is? It's also a timestamp. It's a Unix timestamp. Yeah, awesome, right? And then you have, and this is a Wikipedia access log. So this would be the request and component here. Okay, so if you want to parse this also, in addition to the sys log that we've just seen, you had to write another little script that parses all this stuff in, right? Okay, so let's look at another log. So I don't think I have this prepared, so anybody knows what this is? Okay, so one of these entries, this is an Apache log. Okay, so it starts off with an IP, then would come user authentication, again a timestamp, the GET request, the referrer here, so who referred the user actually to this resource, and then this is the resource that was actually requested here. Oops. And then comes the actual agent that will tell us something about what browser, for example, that user uses, what OS is using, and so on and so forth. And as you can imagine, I mean, such an Apache log holds an awful lot of information along the IP. I mean, think about it. You can get from the IP, you can get an idea where this user is from. It might not be accurate, but you can get an idea where it's from. You can know what kind of browser versions you actually have to support on your web page by just looking at the agent and all that. But still, you would have to ingest all this data, okay? And that's a pain, okay? So, and the way you can do this easily in a modular way is Logstash. Okay. Logstash, in a few sentences, is a Ruby application that allows you to collect, enrich, and store data in a very easy way. And it's particularly designed for large data. That is, if you have giga or terabytes of data that are constantly flowing in. Okay? And horizontally scalable means as more data flows in, all you have to do is add more nodes and more Logstash instances, and this will just scale. And the best thing about it, it's open source. Yay, it's Apache 2. Okay, so the basic idea of Logstash is that it has 3 components, which are completely modular. So you have an input component, which would just connect to this resource that actually passes the message. Okay, this can be a data store, it can be a particular log file, it can be actually any file. It can be some monitoring system, it can be some queue like RabbitMQ, all these different things. It takes messages from there, and then the second component is the filter. The filter would allow you to parse these messages, to enrich them with, for example, information about the geo IP or about the user agent, as we see in this log before. Mutate this message, transform it, and then output it to somewhere else. And this is the third component. Logstash has many outputs. So you can write to various data stores, email, PagerDuty, various chat programs, and so on and so forth. And the cool thing about it is really modular. So if you want to switch your output, just because you change your data store, you don't have to change the input and the filter. You really only have to change the output. Okay, so just a quick example on how this would look in practice. So if you, what? Oh, okay, sorry. Okay, if you download Logstash, what you would get, it's just this tar file, okay? And all you have to do to get Logstash started is just 2 things. The one is just unpack it, okay? So just unpack this thing. And the second thing you would have to do is you have to write a little config file that tells Logstash which input component, which filter, and which output component actually to use. Okay, so let's look at the most simplistic config file that you can think of, and that would be, so this would be this little one. In this case, we say, okay, the input is just standard in. So once Logstash starts, it'll just read messages from standard in. Okay, it'll do nothing with them, and then just output them to standard out. Okay, which might not seem very interesting, but I'm just showing you for presentation purposes. The only thing I'm saying here, I'm changing here is give me the debug output, so just so that you know what's actually going on. Okay, and then to start Logstash, all you have to do is say, okay, start Logstash with this command, point it to the actual config file. Oops. And then it'll start reading whatever you type into the command line. Okay, so for example, if I now type hello, it'll do several things with this message. So first of all, there's going to be a field that's called message, and that will contain whatever you typed in there. A version, which is really just an internal thing of Logstash, so we can ignore it for now. It'll automatically add a timestamp for you. That is, when was this message actually received, and add the host name, at which host this was actually received. Okay, so this might not be super interesting, because really what we're interested in is how can we get more information out of, for example, this Apache log that we've seen before. Okay, so just once more, to show you this, oops, this is really what you want to parse. So what you would need is the third component that I was talking about before. This is this filter component. Okay, so how could a filter for such an Apache log look like? And then again, I'm just going to show this. So here's how a filter could look like. I'd actually love to go into all the details and explain all the different goodies that come with these filters and how to use them, but I can't. If you have a detailed question about what the different filters can do and what kind of different filters we have, you can find me later at the Elasticsearch booth and ask me or one of my colleagues. But for now, all you need to know is the most important filter for parsing log files is the grok filter, which is just an easy way to define sort of regular expressions. And then we have two more filters here, which is the date filter that will actually parse an actual date from a string, and the GeoIP filter that will enhance the IP that was parsed with particular information, and the user agent, which will make sense of this user agent file that we've seen before. Okay, and output is again standard out. So, and just to show you how this works, again we can start Logstash again, as we did before. Point it now to this different config file. And then just copy and paste any of these lines into our standard in. And then see what's happening. Okay, so here's what's actually happening. So it takes this message, again, puts it into a field that is called message, but then does much more with it. Okay, it parses the client IP, it parses the timestamp, what the request actually was, what was the HTTP version, status code, how many bytes were transferred, who was the referrer, what was the agent, and about the agent, not only what is the agent, but also what is the name of the agent, what operation system was support, what's the major and minor version, right? All interesting stuff. Or for the GeoIP, it's not just the GeoIP, it also gives you the different country codes. It gives you maybe sometimes even a city name, and might even give you an area location, such as latitude and longitude, which might not be exact, okay? But if you have lots of these logs, it might give you some information. So, and the message here is, while I cannot go into the details, right. And then, of course, I mean, it tries to parse it, right? But if I just press return, it's not really a message, so it'll tell you, oh, no, no way, no can do. Okay, so the message here is, you have these log files, you have lots of them, and all you have to do is to write this little config file that I showed before that is really, really short, and suddenly you can get all this information out of it. Okay, awesome. Okay, so so I said before, Logstash has many different outputs, such as data stores, email, and so on and so forth. If you want to know everything about these outputs, either you can find us at the booth, or you can also just go to the Logstash homepage and check out the spectacular documentation. So the Logstash documentation is spectacularly well written, I think. Okay, so you can just go there. There's a huge list that tells you everything that you need to know about all the different inputs and outputs. Okay, but the output we'll be talking about is really just Elasticsearch. Okay, so what is Elasticsearch? In a nutshell again, it's written in Java. It's schema-free, so it's by the NoSQL track here. JSON-based, meaning it can just ingest everything that comes in JSON. And then the one thing, and I really apologize that I don't have this on the slide, it's based on Lucene. Okay, you can think of Elasticsearch basically as distributed Lucene. And Lucene, just in case you don't know, is this search library. This is Apache search library. Okay, so it's a search engine. And just like Logstash, it was really designed for scaling horizontally, meaning that if you store your documents with Elasticsearch and more data flows in, all you have to do is add more computers, start more Elasticsearch nodes, and this will just scale. And again, it's open source, Apache 2 license. Okay, so let's take a look at how Elasticsearch looks like. Again, if you download Elasticsearch, just like Logstash, you would just get a tar GZ file. This is the beta. Actually, 1.4 GA came out yesterday, but I forgot to download it, so I'll just be demoing the beta, which is also cool. But yeah. And then just like before, all we have to do is just say, okay, untar it, and that's it. That's all you have to do, and then you can start Elasticsearch. Now, for the purpose of this demonstration, I told before Elasticsearch has a backend, and you can communicate to it, for example, via HTTP and curl, but this is not really nice to show, right? So I'm just going to install one more thing for Elasticsearch just to make it easier for you to see what's actually going on, and that is Marvel. That's a plugin for Elasticsearch that would allow you to monitor Elasticsearch, and then also comes with a nice user interface that's called Sense. That makes it easy to execute queries against Elasticsearch. Okay, Marvel is unfortunately not for free, although it is free in development. So, yeah. Okay, and then again, just like Logstash, it's just started with this command and then it'll run. Okay. So I said before, and I just want to prove that this is actually the case, you can talk to it via curl. So for example, you can say, okay, is it really running? Per default, it'll listen on port 9200. So is it up and running? And yeah, here it is. Okay, so here's the status code. Okay, 200 is there. The name will always be some Marvel superhero if you do not define anything else. Okay, so in this case, the Tomorrow Man, I have no clue who that is. Okay, good. Oh no, not supposed to see that. Okay, so this is Sense here, which I opened just for demonstration purposes. Okay, I said before, it ingests everything that that comes in JSON format. So for example, here we would say, okay, I give you this document, it just has a field text, and in this text is hello. And the way Elasticsearch organizes documents is in two sort of logical units. The first one is an index, and you can roughly think of an index as one database, and then a type. So you can roughly think of a type as a table. Okay, this is the basic association. So in this case, I would say, okay, I call the index test index, and I call the type doc, and I give it an ID. Say, okay, hello. And it says, okay, the document is there. And then when I want to search for it again, I can execute a query. For example, this would be a match query. Just give me all the documents that have hello in the field text, and it would say, yeah, here's a document. Okay, if I look for hellos, it would say, no, there's no document. So this part here, the query part, this is actually the important part in Elasticsearch. Elasticsearch query language is really huge, very powerful. Comes in many different ways, and I will not be talking about it at all. So if you want to know more about Elasticsearch, how it works, want a really good introduction and know all about the query language and all the different goodies that come with it, you read this book. It's Elasticsearch, The Definitive Guide by my two colleagues, Clinton Gormley and Zachary Tong. And this is really the best introduction you can get into Elasticsearch. Okay? All right. So now we're actually ready to ingest this log file that I've shown you before and put it into Elasticsearch. So now, the first thing, we need again this config file. Okay, that will allow us to parse and store it to Elasticsearch. So the config file would in this case just look like this. Oops, oh yeah, right. Sorry. Again, we take it from standard in. We have the same filters that we had before, and the only thing I have to change here is the output. So, okay, output is now Elasticsearch. I'm using this protocol HTTP. Actually, you do not even have to add this line. I'm only adding it because I later on will be showing Kibana 4, and Kibana 4 needs Elasticsearch 1.4, but Logstash per default uses Elasticsearch, I think 1.3 some node. So this is the only reason why I'm putting this here. Usually you don't have to. Okay. And then to just get stuff into Elasticsearch, what you do is just cat was the sample log, and we pipe it into Logstash. And again, pointed to the config file, which was in this case the this config file. And that's it. And now all these lines from the sample log will be read by Logstash, will be parsed, put into this format that we've seen before, converted to a JSON document, and then sent to Elasticsearch for indexing. Okay, before we look at this, there is actually a few things that we need to know. The first is, as I said, Elasticsearch organizes documents and indices. And what Logstash does is per default, it says, okay, just create one index per day. And whenever a message comes in, and that has a timestamp, check out which day this would fall into, and this is then also the index that this document would be indexed to. Okay, this is just per default. Okay, so let's see if we already have something. So if we search, yay, there's some documents. So far, 12,585. And then we can see it's actually the same documents that we've seen before, just now in JSON format and indexed in Elasticsearch. Okay. And now we can start asking questions. For example, how many people that visit my website use Windows? 5,100, no, 5,200 so far. And how many Mac users? Less. Interesting. So what's the most often used operation system? That's an interesting question, right? And you don't want to go, you don't want to go through all the different operation systems and look like, okay, but Mac and Windows and what else do we have? Instead, what you want to do is you want to have it the other way around. You want to have it give me all the operation systems that that we have, and then count and give me the maximum. So which one was most often requested? And this is what we call an Elasticsearch and aggregation. Again, to explain the details of this aggregation, I have to refer you to this wonderful book. But for now, just in brief, how it works. You say, okay, you define an aggregation, give it a name, and in this case it would be terms aggregation. So the information about the operation system, for example, we have it here in the user agent.os. So I say, okay, just aggregate all the terms in this user agent.os field, and then count. And then what you would get back is something like this. Okay, other. I never tried that operation system. I'm not sure if it's good, but okay. And then we have Windows 7 followed by Linux, followed by Windows XP, and so on. Okay, but there's of course more things that you want to know. You might also want to know, okay, just how many requests per day, right? So how many requests per day? You would then use a date histogram. It's called date histogram. Again, look up the syntax in this wonderful book. And then this date histogram will say, okay, per day in this case, just count all the documents. Okay, that would give me the doc count for 24th of May, for the 25th of May, and so on and so forth. But we could often go a step further. We could say, okay, tell me what was the most popular request for each of these days. Or no, wait, tell me what was the request that caused most traffic on this day. Okay, so you would end up with something like this here. And I'm not going to explain it, I'm just going to execute it. So this is also an aggregation. And that would create for me one result per day, and then per day, again, it would split this up into the most popular requests, which would then be sorted by the sum of the bytes that were actually transferred. Okay, and then we can take a look at that. And frankly, if you look at that, it's all nice that this is possible, but it's actually not much better than the original log file that we had before. So which was the most popular request on the 25th of June? No idea. Okay, so which brings us to the last component that I actually want to talk about. That is Kibana. Okay, which would allow you to actually visualize all this stuff. So Kibana, again, in a nutshell, it's an in-browser JavaScript application based on Angular, Flat, and D3. And it speaks to Elasticsearch via these aggregation requests that you've just seen before, but allows you to actually construct these aggregation requests with a nice user interface, and then also makes nice visualizations of these. For example, bar charts or pie charts, if you're into that. I'm actually not, but yeah. And then again, it's open source. It's for free. Okay. So, yeah, there's maybe one more thing I should say about that. I said before it's a beta, right? So it's a beta. And I'm going to demo it now, Kibana 4, right? And, well, the thing is, it is a beta, but The GA is still a little further away, and in the latest beta that was released, not only is it a beta, but also some of the really good goodies that will come are actually missing in this last release. So, so what I did for you is, I just will give you an overview of what's about to come, and I created a little Kibana branch for you, and where I just merged together all the different pull requests that I like, and to give you an overview, and I'm going to run from this branch. Okay, so now we're entering the danger zone. So, okay, I started it already, right? Kibana's up and running. Usually what you would have to do is actually, again, just like Logstash and Elasticsearch, you just download it from the web page. You get this thing, you untar it, just start it just like the other ones, and they will just run. Okay, but well, now I'm running from grunt, so let's see how that goes. Okay. So Elasticsearch, Kibana 4 per default lists on port 5601. When you start it up, the first thing it's going to ask you is, okay, so what index do you want to look at? Now we just index log files, and as I said before, they start with the Logstash pattern, Logstash dash, and then something else. So I'm just going to leave it here, the default. It'll ask me for a time field name. You can actually say, okay, I want to look at data that has no time-based events, but for now, it's time-based events, so we're just going to leave it this way. Create it. Next thing is going to show me, okay, and this is all the fields you have in here. And then there's 3 tabs that are basically important. And I'm just going to talk about 2 of them. First is the Discover tab, which is just the part that allows you to say to figure out where your data actually is. Okay, so no results fault. That's a bad thing. Maybe my data is just a little older. Okay, so let's take a look. So I can say, okay, just show me what was going on in the last 15 years on my Logstash indices. And then we see, okay, something's going in here. Apparently this log file was from 2012. And it would give me a nice overview over what kind of data it is. So this would just aggregate, depending on what the resolution is and what it can actually render, per day, or in this case, I think it's per 12 hours, how many requests came in. And you see this nice seasonal pattern here, so I would expect that this is actually during the week and this is on the weekend, because on the weekend people have other things to do than visiting web pages. Okay, so this is how it looks like. And then it'll show you also show you all the different messages. For example, here it would give you a nice overview of what you have in these fields. And it'll show you the same thing in JSON, which is really ugly, so you shouldn't use it. So this is, okay, the message here is this is a basic idea to give you an overview of what's actually in your data. But if you want to know more, like the things we've just seen before, what you want to do is you actually want to go to the Visualize tab and create a visualization from that. Okay, and here's how this would look like. So first of all, I say, okay, I want to look at the Logstash index as before, and let's start off with a vertical bar chart. Okay. Which would in the beginning be, well, very uninteresting, because it really just tell me how many documents are currently indexed. And then we can add this aggregation that I was talking about before. For example, we can say, okay, make a dates histogram on the x-axis. Timestamp field is actually the timestamp field. Make a daily histogram. And then let's see how this looks like. Okay, and this is basically roughly what we've seen before. Actually, I'm wondering if I can just, yeah, that's better. That's basically what we've seen before, okay? Similar seasonal pattern, but not more interesting than what we've seen before. So the next thing that we could look is, for example, say, okay, what was the traffic? How many bytes were actually transferred? Okay, so to do this, I can configure the x-axis, y-axis configuration. Y-axis configuration and say, hey, just sum up all the bytes per day. Okay, and this looks very different, and you might notice here already that this is much different from what we've seen before. I mean, we would expect if the traffic sort of follows the same pattern as the general axis, then this should be okay, or we would expect that this would be the case, but it's actually not the case. There's something else going on here. Okay, I'm just going to quit this. Makes me nervous. So the next question we could ask is, okay, so which was the resource that actually caused this traffic? Okay. What was the resource? Okay, so we can say just, okay, split the bars and sort it by terms, and by terms I mean the request. So let's take a look. What was actually requested? And this is actually rather interesting because we can see here that all this traffic, or most of this traffic, was actually caused by one single file. And now you can guess where this log is actually coming from. So this is actually the old Logstash web page. Okay. So all of this was caused by this one file, and this is a little weird. So the next thing we might want to figure out is, okay, so what's the agent? Who downloaded that stuff? Were there people clicking on the web page? Was there maybe a seminar going on, right? And all the 5,000 students that were connected online on the world downloading Logstash at the same time, or what was actually going on? So let's look at the agent. I'm just gonna, oh yeah, good. Okay, and this is also rather interesting. So what this tells us is that it's basically all just chef clients. And I mean, this year, okay, I would argue that maybe this is okay. Somebody had their chef client running. As I said, I'm not an ops person, okay? So, but this year seems a little fishy to me, okay? So the next question we could ask is, okay, who does that? Maybe I can figure out a phone number and call these people and say, hey, you screwed up your chef configuration. There's a different kind of visualization that we can actually use for that. And we can use a tile map. So a tile map would tell me something about where in the world stuff is happening. Although, as I said, danger zone. Apparently this doesn't work with the resolution of my screen, so I'm terribly sorry. If you want to see how the tile map works and how it can give you a wonderful overview of where in the world people visit your web page, then please find me at the booth later and I'm going to show it to you. But here, unfortunately, it will not work. That's a shame. Okay. But it's actually not so bad because I'm running out of time anyway. So, okay. Good. Actually, I said before, I want to show you two data sets. Okay, one was this Apache log, and the other one was this Wikipedia access log. Okay. So I cannot actually show you this Wikipedia access log or index it on the fly because it's a little bigger than the thing which we've just seen. So I prepared it for you. Okay. So I'm just going to start another Elasticsearch instance. So what I'm going to do is I'm going to just say give Elasticsearch a little more heap space. For Gigabyte it's probably too much, but better safe than sorry. Again, start Elasticsearch as before, but point it to a different data directory, just to make sure that the data that I actually index is loaded. Okay. Okay. While this is starting up, I'm going to talk a little bit about the actual data set. So first of all, the Apache log that I've seen before, if you want to play around a little bit with Logstash, you can get it for free on this webpage, semicomplete.com, which is the old webpage that actually hosted Logstash, apparently in 2012. And the other data set that I'm going to show is a wiki access log. So you can get it from wikibench.eu. And this is a spectacular data set. Any one of you ever seen that? No? Wow. Okay. It's 2 months of access to Wikipedia. It's actually designed for benchmarking your own web server. So you can download this and you can get a Wikipedia dump and then execute all these commands against your server and see if it crashes or not. Okay, this is what it was originally designed for. But from a data analytics perspective, this thing is pure gold. It's amazing what you can see in that. Okay, and I'm just going to show you not the whole data set because the whole data set is, I don't know, 500 gigabyte or nearly a terabyte. I'm just going to show you the logs from the German Wikipedia, and only the pages that were requested. Okay, so everything that starts with te.wikipedia.org/wiki, this is what I'm going to show. And that's going to be 70 million entries. Okay, let's see if we're here yet. Yeah, looks good. Okay, so first you got to do is reload Kibana. This is actually on a different index. So this is the name of the index where I had it. And then again, we have to figure out where our data actually is. So let's see where this data actually is. Okay, here's our data. Oops, sorry. Okay, can zoom in a little bit. Zoom in a little more. And then we have this a similar thing that we've seen before, okay? So we have a weekly pattern, apparently. I would argue that this is probably during the week and this is on the weekend. Okay, and then also a daily pattern in this case. So this is probably day, this is probably night, probably day, and probably night. And the reason why this is much more impressive here than it is for this Apache log is because this is really just German Wikipedia. So we would expect it's really just Germans that access this stuff, or maybe a few from another country, but well, maybe not. So, okay, and then we can start asking questions about this, in this case, just 1 month of German Wikipedia. For example, we can say, okay, so what was the most popular page? Okay, and the title here is actually wrong. So what I'm doing here is I say, okay, split the lines by the most popular page over all 4 weeks. So this would first aggregate all the pages over these 4 weeks, and then tell me, okay, how are these? Does the access evolve over time? And there's already something interesting we can see there. Okay, maybe not so interesting as the fact that the main page is the most requested page, but this is interesting here. So what is this? Anybody knows? Ah, you can, because this is not rendered here. Okay, so this is 3rd of October, which totally explains this dip here. Okay, nobody in Germany does anything other than partying. So, well, maybe not. Okay, but this is not. This is not super interesting because the main page just renders everything else invisible. So a second thing we would probably do is get rid of all these Wikipedia meta pages like portal or things that start with Wikipedia or with special or with special. Or so let's filter them out. And the way you can do this in Kibana is you can just define a filter on this top row here. It's a very easy query language. So we just tell you, okay, on a page, should not be main page, the page should not be special, and so on and so forth. And then what you would get is this here. And this is a little more interesting. So this gives us the most requested pages, but you can also see some peaks here, okay? So this peak here, for example, I mean, this is something that we've seen before. People want to know about the day of the German reunion. Here is a peak. So this is Heroes. Heroes is a series, so I'm not sure who of you knows this. Heroes? No? Okay. And the 10th of October was actually the first air date of the first episode of the first season of Heroes in Germany. And here was the second episode. Okay, so you can see these peaks here. And I assume this is King of Queens, but I was not interested because I don't really into King of Queens. So, okay, this is also interesting here. Okay, so this is Myanmar. So anybody knows why there's a peak for Myanmar at this point? Yeah. Okay. They had a revolution at this part, and the revolution had the peak at this point. Okay, and you can see this actually also easily if you look at several related topics, something that is related to this. You can see, okay, Myanmar has a peak. Junta also sort of has a different behavior here, okay? And Aung San Suu Kyi has a different behavior here, and I probably mispronounced this, but and Bhikkhu, which is a Buddhist monk, okay? So people were looking up this word very frequently. Okay, so this is all interesting, but there's actually another way we can look at our data. So instead of asking, okay, what was the most popular page, and then plot this over time, instead tell me what was the most popular page per day, that is bucketed first per day, and then give me the most popular term for these days, okay? So, and now I'm just going to show this in a different view. It's not going to be in a curve view, because as you can imagine, if you do it per day, you end up with way more terms, way more curves, and this will not tell you anything. So I'm just going to look at the table view here. It's another nice fancy feature that's coming out with Kibana. Okay, and this will tell me, okay, 18th of September, apparently the main page was the most important page. Jim Morrison was requested here. Well, this is interesting, and we're going to look at this in a minute. 19th of September, only just meta pages, 20th of September, only just meta pages, and so on and so forth. Again, not very interesting. However, so what we could do now is we could do the same thing that I explained before, go to this thing here, go to this tab here, define a different query, that would filter out all these things, but there's actually a smarter way to do that. And it's instead of doing a term aggregation here and just count the popular pages, we could ask, okay, don't just tell me how many documents contain this term or how often this page was requested, but tell me how much more often it was requested on this day compared to all these other days. Okay, and this is what we call a significant terms analysis. Different terms analysis. So again, we would execute this on the page. The page field, and that would then show a very different pattern. Okay. So again, Jim Morrison apparently was popular on that day, right? But then we see something else. I'm actually not even know how to pronounce it, and I cannot tell you why it was popular on that day, or Howard Carpendale. On the 19th of September, there's something interesting. Apparently, the 19th of September was an interesting article on that day, and that makes a whole lot of sense, right? Faustrecht der Prärie might seem a little weird to you, but then when you go to Wikipedia and look up the article of the day, what you will find is that, yeah, this was the article of the day on the 19th of 9. Okay, so this all makes a whole lot of sense. You get the 20th of September on the 20th of September. ISS expedition was, I think, also the article of the day. I'm not absolutely sure. Yeah, all that sort of stuff. So this is interesting. But now let's focus on Jim Morrison. Okay, why was Jim Morrison interesting on the day? And I can tell you already, Jim Morrison did not die on the day, did not have a birthday on the day. There was actually nothing. It was not the article of the day. Okay, so let's take a closer look. So I can again look just at this bucket aggregation, so how many requests of Jim Morrison per day were there, and then we want to zoom in on this particular date. Okay, so let's go back to the Discover tab because this is where you can brush. You currently cannot brush in the Visualize tab, and look for just Jim Morrison, and then let's zoom in just on this particular part. So that would be this here. Okay. Now as we go back to the Visualize tab, we can see it a little better. Okay, and this is again the part where the danger zone starts. Here would be a very impressive timeline that would tell me something about how many requests at which time of the day, okay? And unfortunately, I now cannot prove it to you because it's not rendered. I promise I'm going to open an issue and we're going to fix it. But unfortunately not so. And this is really a shame because the funny thing here is what you would see is that this is actually 20 to 1 a.m. in the morning. This is actually at something like 10:30. Okay, so something happened between 10:30 and 1 a.m. in the morning. And then I looked up a TV program from 2007, Dreisat, and check it out. There was actually one they aired the film. Yeah, and I found that amazing. Okay, and this is all just with a few mouse clicks. At 70 million documents, it runs on this little computer, a few mouse clicks, wait a few seconds, and then you can figure it out. And then all you have to do is Google a lot to figure out why this is actually a significant term. Okay, good. Okay, that was it for the danger zone. Here come all the backup slides in case anything would have happened. So one thing you should know about, I was boasting a little bit with the 70 million terms and all that. Terms aggregations can be inexpensive. Okay, so if you actually plan on using this on your own cluster or even run it in production, there's a few things you need to know, and I'm just going to briefly mention the buzzwords, hoping that you will later on look it up if you actually use this. So first is a field data filter. Query cache is a new feature. It comes in 1.4. That will make it easier to store results of queries and not execute them again if it's just the same query. Warmers is interesting, and doc values, which is a way to actually not have to load everything into memory, but just memory map everything. Okay, this is also a rather new feature that you should really check out. And I'm just putting this on a slide because I'm telling everyone, regardless of what I'm talking about, before you move to production with Elasticsearch, watch this video. There is a video that tells you everything about what you need to know, what you need to take care of, things that might nuke your cluster. It's all in this video. Okay, watch it. Okay. So I talked a little bit about the basic aggregations, but we actually have a little more. So we have, for example, percentile aggregation, which is not yet integrated in Kibana, but it's on the roadmap. A cardinality aggregation, significant terms I showed. And then coming soon, there will be much more. Okay, so we're thinking about maybe adding derivatives, correlations between curves. For example, this Myanmar thing would be cool if it would happen automatically, okay? But it's not sure yet. There is an open issue. If you have something that you totally want to see in Elasticsearch and you're thinking, wow, yes, with this algorithm and this data it would be awesome to have, check out the GitHub issue. It's issue 8110 and drop us a note and say, okay, I want to have this. This is the algorithm I would expect. And let us know what you think, because this is really work in progress. Okay, and that's actually all I got. We're hiring, needless to say, I think everybody's hiring. And then Elasticsearch, the company, I mean, I was talking a lot about the software. The company, we're actually offering support and trainings. So in case you're running Elasticsearch in production, yeah, give us a call. Okay, that was it.
Thanks a lot. I have 3 questions written down. Is there anyone who wanted to pose a question now?
So what happened to, hey, I have a question.
Yeah.
Let me see.
Can you read it? Predefined config files is the first one.
Predefined config files. Sorry, I cannot read that anymore.
Oh.
I saw it.
For Logstash or
for Apache log and everything. Yeah, actually, there is. I don't think there is anything on the Logstash webpage. There is examples for. I think there's definitely one for Apache log. One thing that is nice about Logstash is there's a big community around it. So if you Google a little bit, you will probably find a config file or sample config file for everything, just because the community is so great and writes a lot of blog posts about it and offers everything to the rest of the community. So, yeah. What do you want to say something about that?
I'm pretty sure on GitHub in the Logstash contrib repository, there are also some sample config files there as well.
Ah, all right, cool, awesome, yeah. Thank you. Okay.
The second one is, how do you get log files scattered across multiple hosts to Logstash? Do you need a messaging queue?
Yeah, you can use a messaging queue for that. I mean, this is Logstash can read for RabbitMQ. There's also another thing that's called the Logstash forwarder, but please do not ask me about the technical details of that. Find me later at the booth. There's me and more colleagues, and then we can figure it out. But yeah, this is the basic idea. You would use a queuing system of one way or the other for that.
Okay, the very last. Can ELK be used for monitoring, or is it rather for analysis?
For both. So the original development of Kibana, there was actually a system administrator. It was Rashid Khan who thought, hey, this should be really easy, and this is why he actually built Kibana 3, and it was for monitoring. You can configure it so that it will load automatically every 5 seconds, every 1 minute, or something like this, and just always display your graphs. Okay,
also alerts or
alerts. Okay, so alerts currently not. No. So currently you can visualize your stuff, but there's no automatic alerting. If it's a message-based alerting, of course you can use Logstash for that and just output something to PagerDuty, but there's nothing like basic thresholding that would then say, okay, now send a mail because memory pressure is above this and that threshold. So, yeah.
Okay, see you at half for the next talk, and thanks again for Britta. Okay. Thank you for coming.